Today's lesson, we're going to talk about logarithmic functions. What's the logarithmic functions? Well, this is the basic shape of log. And where this come from? Well, that's equivalent to your exponentials. So you have exponentials. B to the x exponents equals to y value, right? This is unknown, right? If you want to, you can convert this into the logarithmic functions, which you will have log b to the y is equals to x. So I'm going to give you an example why we're going to use log, something you never heard of before if you never had logarithmic functions. Can we just solve exponential as it is? If you have 2 to the x exponent equals to 4, then yeah, that's easier to solve. Your exponent's x should be 2. 2 squared is equals to 4. So you know x should be equals to 2, right? But what about if you have something like 2 to the x exponent equals to 3, right? Because you don't know what you need to have exponents to become 3, you don't know how to solve that. What you can do is this, convert this into the logarithm, will give you log 2, 3 is equals to x. So that way that if you understand a little more about logarithm, you should be able to find these solutions, this exponential solution using your logarithmic functions like this, right? So log 2, 3 is going to be what x is, and that x is going to be same x for your exponential right here, this x, okay? So you're going to use logarithmic to solve some of the exponentials. So we're going to go over a little bit about logarithmic functions. We have a property of logarithm. When you have larger base, so the logarithm, we call this is small base, this is larger base, and this is solutions, right? So if you have a larger base is equals to 1, no matter what you have for the small base, this is always equals to 0. Why? Because this means any numbers to 0 exponents should be equals to 1, right? And logarithm, when you have small base, larger base, same, it means your solution is going to be 1, right? Because that reason, exponentials with the first exponent will be itself. When you have logarithm with small base, larger base, same, but then larger base had exponents, that exponents will become your solutions. So this is some of the rules you can use, property you can use to solve for logarithmic functions. If you have logarithm as the exponents, and where your base with the small base on the log is the same value, larger base will be your solutions, okay? And there is some example you can follow. Again, we will do some of examples to get better understanding of the property of logarithm. The logarithm functions, remember this is exponentials, right? This is going to be logarithm graph. They are inverse to each other, so when you draw this diagonal lines through the graph, when you fold this graph should be match of exactly same graph of your log, right? Let's see. And there's some basic informations about exponential graph with the conditions, right? We talk about it from the exponential. The logarithm will have the same thing, but on the side, right? Not on the top. It will be on the side, up on the right side of y-axis, and their conditions. So example of logarithm will be pretty much going over some basic properties. Or in the beginning, we wanted to make sure how to convert one from the other. So if we have a logarithm given, we wanted to make sure we know how to convert it into exponential form, or exponential given, we wanted to know how to convert into the logarithm. So I will show you how to do that. Example A, make sure small base will be the base of exponents. 4, which is the solution of the logarithm, will be the exponent, equals to larger base. And this makes sense, right? 2 to the 4th exponent is 16. We have more information. We are more familiar with the exponential. That's how we can tell this is true. But just looking at this, you don't know if that's true. You can also convert this into the logarithm property, and you know that's equals to 4. Remember, when our property says small base, larger base is same, then exponent is the solutions, right? But just looking at it for the first time, you have no clue what you're looking at, right? We're more familiar with exponential at this point. That's what we're trying to get, familiarizing your logarithm by converting from one form to the other form. This one to the exponential will be 10 to the negative square equals to 1 over 100. And we know that's also true. This negative become this base to the denominator, right? So this become 1 over 10 to the square, and then that gives you 1 over 100. This one will be 7 to the 0 exponent is equals to 1, and we know that's also true, right? But again, we're just exercising how to convert one from the other. So this one, exponential, it will be log 3 to the 81 is equals to 4. So exponent will be the solution of logarithm. So if you wanted to change this into the English language, this math sign into the English language, it means that what exponents you need to have 3 to make 81. That's what it's saying, right? What exponent you need to have it for 3 to make 81? Well, that will be 4. So let's try this one. So it will be log 10 to 1 million, right? Is equals to 10 to the 6th exponent. I'm not trying to explain if this is true or not, because right now, again, we are just exercising how to convert. This exponential logarithm will be log 1 over 5 to the 5 is equals to negative 1. Right? So this is how you're going to change this exponential into the logarithm. What exponents you need to have for 1 over 5 to become 5? That will be negative 1, right? Okay, next example is evaluating. So we're going to remember some of those properties from the other page. So let me see if I can go over. So this property right here, this property. We're going to use this property to see if we'll be able to answer some of the questions from example 3. Or, most of the questions from example 3. Okay. So this, I can rewrite this as log 4 square, because 16 is same as 4 square. Why do I do that? Because I remember having same small base, larger base, exponent will be the solutions, right? So that will be the solution of that. So pretty much what this is asking is what exponents you need for 4 to become 16. 4 square is 16, so it will be 2. Let's do this one again. What exponents do you need to make 2 to become 8? So 8, I know that will be 2 cubed, so your solution will be 3. What about this one? If the property of logarithm do not work out, then or you're not really getting it, then what you can do is you can also convert it into exponential, right? So this logarithm, if I wanted to convert it into exponential, will be 1 over 2 to the x exponent is equals to 8. And we can solve this exponent by making a same base. So that becomes 2 to the first exponent. And 8 is 2 cubed. And this is going to be 2 to the negative x exponent equals 2 cubed. Once you have same base, drop the base, let the exponent equals to each other. So x should be negative 3. Right? And you should be able to check that. If you have 1/2 to the negative third power, that's going to be 2 to the third power, which is going to be 8. Right? This one, if you don't see any small base, right? If you don't see any small base, it means you have log 10. So this is going to be log 10, 100,000. And 100,000 in an exponential is 10 to the 1, 2, 3, 4, 5 zeros, so it will be 5th power. Same small and larger base means exponent is the solutions. So that's how you know that will be equals to 5. This is same thing as log 10. That's going to be 10 to the negative third power, right? So if you have 10, your decimal is right there. If you do move decimal 3 space, 1, 2, 3 space. Well, not 10, from the 1. Hold on, let me erase that. From 1, if you have 1, you move 1, 2, 3 space, it will give you 0.001, right? So that's what 10 to the negative third is equals to. This is going to be negative 3. Right? This one, what's the ln function? Ln, right? Ln, ln function, is same as natural logarithm. Log to the e. And then you have e to the 4th exponents. Same small and larger base means your solution will be the exponents. So that's another one that you need to remember. So what was one? Ln L n is same as natural logarithm. The log with e as the small base. Right? So that's important to remember. That's one of the properties. And here's another one. If you have log with no small base, that's same thing as log 10. Okay, so let's answer the next one. So this is going to be same as log e to the negative first exponent. So that's going to be negative 1 as the solutions. Example 4, simplifying. So we're doing same thing. evaluating, simplifying, right? Same small base, larger base, exponent will be the solutions. This is going to be ln is same as log e squared, so that will be 2. If you have a same small base, larger base, then 1 is the solutions, right? This one don't see small base, so it means 10. So your solution will be 1. This one you have log square root of 7, 1 means that square root of 7 to the what exponent is equals to 1, right? So when larger base 1, this is always equals to 0, because only way this value will be equals to 1 will be when exponent is 0, right? This one will be the same thing. This is same as log E1, so that will be 0. Again, when larger base is 1, solution is always 0. This one is log as exponents. And this small base and base is the same. So your solution should be, is that a squared plus 4? The larger base, okay, let me write it better. A squared plus 4, right? Larger base of that logarithm exponents. This one will be the same thing, since base with this logarithm small base is same, so the larger base of that logarithm will be the solutions, right? So that's all from the property of logarithm. I will do 2 more examples from these sections. The one will be graphing. So if we don't know the shape of it, what we can do is, again, plug in the points like we did it for exponent, right? This time, I will see what happened when x is 4 and x is 1, right? So when x is 1, we know that solution had to be 0, right? So any logarithm to the first 1 into the larger base is equals to 1, right? 2 to the 0 exponent is equals to 1. So that's how you get 0 there. When x equals to 4, you have log 2 to the 4th equals 2. Log 2 squared, so it will be 2, right? So that's how you get that 2. Remember, you have a vertical asymptote on the logarithmic. It was horizontal asymptote. This is a horizontal asymptote for exponential. Logarithm, it will be vertical asymptote. Okay, and your graph should pass on the right side of that vertical asymptote, passing 1 and 0. And when x is 4, will be 2. And you know that's gradually going close to your vertical asymptote, but never touch or pass, right? So that's how you can graph that equations. Using the transformation, because this is the same thing, right? Log 2 is the basic. This is log 2. X, on our x, you have a plus 3 and minus 2. So this is going to give you moving left 3, going down 2 from your graph. So then moving down 2 and moving left 3. So if I move vertical asymptote to move left 3 will be 1, 2, 3, negative 3. So that's going to be your vertical asymptote. It means your x-intercept should be going down 3 from 1, so it will be negative 2. Negative 2, and again, you need to go down 2 also, right? So let me erase that. Moving left 3 makes it negative 2, and going down 2. So it will be that point right there. So you should be able to use the transformations for the logarithmic graph also. Let's see if we can solve the basic logarithm then. So if you have a x in a larger base, right, and you don't know how to solve it, remember always the last method will be converting into the exponential, right? So this change to exponential will be 3 squared equals to 4x minus 7. It was lucky enough it's linear now, right? So it will be 9 equals to 4x minus 7. You're going to add both side by 7. Get 16 equals to 4x, divide by 4 both sides. To solve for x, you get 4. You should be able to check. Always, you should be able to check any solving equations. That's going to be 4 times 4 minus 7, right? That's log 3, 4 times 4. That's 16 minus 7, so it will be 9. And 3 to become 9, you're going to need 2 square, right? And it checks out. So we know x should be 4. Let's try this one converting into exponential. X squared equals to 64. Once you convert it into exponential, you realize this is going to be same as 8 square. 64 is 8 square. So since you have 2 square and square, if I can order your x right here should be 8, right? Then this is going to be equals to each other. So you know x had to be 8. You can also use x squared equals to 64 and square root property, which is equals to plus minus 8, but you cannot use negative. So x should be equals to 8. So that's another way of doing it, right? The third one, what we can do with this problem is trying to bring your exponent down. And in order to bring exponent down, you can multiply both sides by natural logarithm. And by the definition of logarithm, you should be able to bring this 2x in front of the natural logarithm to make it multiplications. That will be 2x ln e equals to ln 5. And also another property that you need to know, ln e is equals to 1. So natural logarithm of e is equals to 1. Why? Because ln is log e. right? So then you're going to end up getting 2x equals 2 ln 5, where x should be equals to ln 5 over 2. Solving equations, we're going to deal with that later on with more detail, but this is the basic ones that we look at in this section.